Hi, today's video is on scientific method, a dynamic model. So this is just a really short video on scientific method. And you're probably familiar with this. Perhaps you've participated in a science fair, and we know that there are certain actions that happen in the course of doing a scientific experiment, and that's what we call scientific method. Please note that there is not the scientific method. And I say that because sometimes some of these steps you may stop along the way, you may backtrack and do some different things, you may skip some for some reason, you may engage in part of it. So a scientific experiment can simply be making observations and collecting data. So you notice that we kind of skipped a lot of steps. Just depends on the nature of your experiment. So there is no the scientific method, but you definitely should be aware of these things that commonly happen in scientific practice. So with scientific method, we typically start with making observations because that's the nature of science. Science is all about the fact that you have noticed something, you're interested in something, and that stimulates you to ask a question. So the question would be about what you've observed. You see this picture here, a girl swimming with a shark. Maybe she notices she appears to be touching this shark, so she notices that it has very rough, scaly skin. She wonders, why would a shark that's swimming in the water seems like it would be more efficient for it to be very sleek and smooth? Why does it have these rough scales? So we have a step here, consulting prior knowledge. One of the things that's really important in science is we stand on the shoulders of giants. So look and see what other people have learned. Maybe someone has already asked this question and done some research. In that case, we're going to go to our peer-reviewed journals and see what's known about the skin of sharks. We formulate a hypothesis. A hypothesis is going to be a testable explanation. Now, there's a myth out there that a hypothesis has to be an if-then statement. It does not. In elementary grades and even up to high school, a lot of teachers use if-then statements to make it a little easier for students to grasp what's happening in a hypothesis. But a hypothesis is a testable explanation, so it's really just a statement. So in the case of the example that we've been using so far, the statement could be sharks with scales swim faster than sharks with smooth bodies. And then the making predictions section is where the if then comes in. Still, it doesn't have to be, but often it is. So it'll be if a shark has rougher skin, then it is able to navigate the water at a faster rate of speed. So you design your experiment. How are you going to test that? You figure that out. You start collecting your data. You gather the data. You analyze and interpret the data. You kind of go back and you compare what you found. So we have this step again, consulting prior knowledge. What was already out there? What did what you find and how did it compare to what else is out there? You draw conclusions based on your experiment. What did your experiment tell you? Was your hypothesis accepted, or was it the null hypothesis, or the opposite hypothesis, which would be something like sharks with scaly skin do not, in fact, swim at a more rapid rate of speed than those with smooth skin? Once you have drawn your conclusions, you could submit that for peer review. So you could submit that to the broader scientific community and say, hey, I have found this, and get comments back. They'll look at your experiment design, decide if it was a good experiment. Was there some bias in there? Were there some errors or things that need to be pointed out? After it's been reviewed, potentially it could be published. And even after it's published, it kind of goes through a more public type of peer review. Now, notice that we branch back off to make observations. So once you've drawn your conclusions, you can make observations about those conclusions yourself without going through peer review and publishing. And maybe you start that experimental cycle all over again. You see that there's something that you need to modify about the experiment. So that's the way that science works. Dynamic nature of various different steps in engaging with making observations, asking questions, and eventually coming to conclusions.